So we're going to talk about a couple of topics this afternoon related to generative AI and LLMs. There seem to be very few topics that can get faculty as passionate about arguing as they are about the introductory programming language to teach, as whether we should be using these LLMs in our research and our teaching. And so we're going to take turns giving short talks, and then we're going to go ahead and have discussion because everybody has an opinion on this. So for my part of the talk, there are really two parts. First is discussing assuring the future of software engineering and AI engineering. Mercifully, I'm not going to give that talk. Instead, you can watch the video recording of the talk that I gave at an NSF workshop from a couple months ago, which talks about this. It goes into great detail. It was lots of fun. Instead, what I'm going to talk about is applying generative AI to my courses of computer science at Vanderbilt. And to paraphrase the wonderful Stanley Kubrick movie, Dr. Strangelove, how I learned to stop worrying and love the bot. So what the heck's going on? Well, one of the things that's really wonderful about these technologies is the barrier to entry is ridiculously low. You basically need a web browser, and if you want something more than just the vanilla version of this stuff you get off the shelf from ChatGPT 3.5 or Bard or Claude or whatnot, you can pay $20 a month, which is like 3 cups of coffee at Starbucks, and you can get access to much cooler things. Now, let's be honest. The large language models today are not yet flawless, and Gabor turned me on to this great article by Peter Denning, where he basically talks about a bunch of problems with these technologies. And what's funny, if you read the problems, this sounds to me like what you get when you have the first semester graduate student come to your lab. Most of what they tell you, it seems like you've already heard it before. There's no radical departures from what others have already said, and so on and so forth. How many of us expect our first semester graduate students to write our proposals successfully to NIH, NSF, and DARPA, to be able to generate journal publications that are going to be accepted into IEEE transactions on blah, blah, blah in the first couple months? Nobody does that, right? But people, for some reason, seem to hold these technologies very high standards. I think that's because we're fundamentally doing it wrong. Rather than thinking about this as generative artificial intelligence, where you try to replace people by outsourcing your brain, we should be thinking about this in terms of generative augmented intelligence, which is really about supplementing, not supplanting, but working together with the person. So in that spirit, I've been doing, for the past 6 months, retooling all of my courses to fully embrace the use of these technologies. And this is courses I've been teaching here at Vanderbilt for a very long time on middleware and distributed computing and concurrency and so on and so forth. And people are building really cool projects using this stuff. These happen to be upper level mezzanine courses, which means that a lot of the thorny issues we deal with when we try to figure out how to teach this at the undergrad level can be sidestepped to some extent because most people already have some foundation in programming. My perspective on this so far has been how to accentuate the things I really like to do when I teach, which is creating lecture material, giving lectures, creating examples, creating programming assignments, and help augment the tedious part, which I do because I have to, but it's not fun. Creating quizzes, creating summaries of things that I need to do in order to make my course palatable to the students. I want to get that stuff and outsource it to something else, but with my help. So let's talk about how I've actually done this real quick. So I've been using these technologies since last semester in the spring to expand my teaching abilities. One thing I always have been trying to do is trying to reboot myself to know new topics I didn't previously know much about. I've been doing work on distributed computing, networking, concurrency, and so on for decades, but I never really had a chance to learn how to do relational and reactive database programming with modern web environments. Just something I never had time to do. I couldn't go back and take a master's degree in this course. So what I've been doing is using ChatGPT in order to be able to generate the APIs I need through natural language prompts. And it does a wonderful job of doing this. It also does a wonderful job of showing my students and me what's going on under the hood. When you use these higher level abstractions, what's the actual query that's taking place? Really good at that. I've also been using it to generate code using techniques that I was not yet aware of, just because I never worked in this before. So one thing I found very interesting was how do you generate custom SQL queries? It's all well and good to use these high-level language programming approaches to program the APIs from the data API perspective, but how do you do things at a more programmatic level? ChatGPT was extremely helpful there. Lots of other nitty-gritty stuff you have to do. Importing various interfaces to make your code work correctly. Commenting, the bane of every programmer's existence. You can find all kinds of ways to have the code commented for you in ways that, at least for me, I would not have thought of myself as quickly. Building project dependencies. This is all the grubby work that makes it less fun to write. By doing the LLM and using the LLM, you can find ways to basically outsource this to something that's not going to get bored and not going to be annoyed with tedious and repetitive work. The other great thing is the new generation of programming aids like Code Whisperer and Copilot and so on will do a lot of this for you automatically now. You don't have to put this into your chat window. I've also been finding lots of good ways to take clever solutions by my students that used to take a while to decipher and reverse engineer, feed it to ChatGPT, it'll tell me what it's doing, and then I can get it to generate even better solutions using modern technologies. And one of the great things about these tools is, unlike me, where I typically only learn the stuff I need to, they read the whole manual. And so they'll come up with solutions I didn't even know existed because they have a more fulsome perspective on what's going on. What's also fun is to be able to do this in multiple languages. So I program in a lot of languages, but I'm not really a Python programmer. It's a failing, I realize. So what I can do is generate the code in Python, and if I really want to take a blast from the past, I can generate it in Ada, which is one of the first programming languages I learned back about 35 years ago. It knows Ada. I forgot Ada, but it still knows it. I can also do other things that are necessary but somewhat drudgery, like generating test cases for my assignments and my examples, and you can automate a lot of this stuff. There's some really good tools out there, such as things like DiffBlue, that will automate the generation of these test cases. I can also use it to explain things more effectively. Sometimes I forget, even though I teach a lot of courses, I forget the details of stuff. ChatGPT can remind me. And this has turned out to be tremendously useful because I put all my videos up on YouTube, and I get a lot of people asking me questions based on my videos. And I like to try to be responsive. It's good to build a community of people who want to be involved with what you're doing, but it can be very time-consuming. Once again, ChatGPT to the rescue. Cut and paste the question, put it in ChatGPT, get back very long answers that I then read to make sure they're coherent, type them into the chat window and reply. People are like, "You're the most useful person ever. You give such great responses." And this is also something I've been leveraging in my Piazza discussion forums, where I can give very, very detailed responses to students. Why they don't just do this themselves is another story, but this is called job security, being able to decipher that they use these technologies. A lot of this stuff is something I never would have been able to do if I didn't have these tools. It would have taken me weeks, probably forever to do it, because I never would even have tried. But now I can do it in hours, minutes, seconds, and get amazing results. So to kind of wrap up here, AI is also improving the way I do the assessments for my classes. So knowledge check questions, you give it your slides with the new thing that's called Advanced Data Analytics. It's a plug-in to ChatGPT 4. Ironically has the acronym ADA. So you can use ADA in order to be able to give PowerPoints. I give it IntelliJ projects, Android Studio projects, zip files, PDF files, all the stuff, and it comes out, reads my PowerPoint slides, and comes up with knowledge check questions without me having to do all the sifting through the work myself. It's also fantastically useful, since I record all my lectures, to go back every 2 weeks when it's time for a quiz, take the transcripts from my videos, and then say, generate some questions based on what I said in class, which is something else that's very, very tedious to do yourself if you have to remember what you said 2 weeks ago when you're generating the quiz. And it tends to do a really good job with this, and it also rewards the students who come to class because the quizzes are about things we discuss, keeps them involved. One of the other tricks is it helps you figure out how to write your programming assignments in ways that are hard to reverse engineer with ChatGPT. And this is one of the most fascinating things at the recent CS offsite we had a couple weeks ago. I sat next to Jerry Roth, wonderful professor, teaches the intro courses, and I said, "Jerry, send me one of your PDF files for an assignment that you think is the hardest assignment in the data structures course." So he sent me this thing, it's about 7 pages long, and I said, "Have you ever used ChatGPT?" "No." I said, "Watch this." So I said, "Please read this PDF file and generate the solution." And lo and behold, in about 5 minutes, it generated a very, very good solution to his hardest programming assignment. And Jerry's reaction was, "Doug, I think it's time for me to retire." That was not the reaction I was looking for, but where I'm headed with this is that in addition to making things easier to generate specs that are hard to reverse engineer, which it does well, we're also looking at this semester at how to use it to help do the assignment and assessment portion of the code review. That's going to be really fascinating because that's something that gets more difficult as you step away from the details of all this stuff. Another thing I like to do is generate the summaries of the videos I upload. Again, you give a talk for a certain amount of time, you tend to forget what did I talk about? ChatGPT once again to the rescue. Read your transcript, give me a 100-word summary, you get it back, you take it, you modify it, and so on and so forth. All right, so to wrap up real quick, where we are headed with this in the very near future is humans and AI tools working together in collaborative ways, maybe trustworthy. We'll see, that's still an open issue. The idea, of course, is to move to things more about intent rather than coding. For decades, the model integrated folks at ISIS had this right. We don't want to force people to program in a low level. You want them to program in a domain-specific way. The problem we've had historically is when people from other disciplines come to us in computer science and they say, we want to use computation to do drug discovery, use computation computation to analyze ancient documents to look for patterns and so on. What do we tell them? Learn to program in Python. Learn to program in Java. That is absolutely the wrong way to go about it. What we need to do is show them how to problem solve using computation. And the great thing about these tools, and I think is going to be the real paradigm shift, is moving towards using this as a problem-solving means, much like we did with model integrated computing, but it's now in natural language instead of whatever the meta model is. And while meta modeling is great, as Jonathan pointed out earlier, most people's minds start to explode when they think about generating code to generate code, and so on. So with that, everybody's going to be a programmer, whether you like it or not. Everybody's going to learn to interact with these language models, whether we like it or not, just like people know how to use touchscreens. Some of us will go on to do more structured programming, but most people will learn to program with these kinds of things. And hopefully that'll help to refocus us on the creative aspects of what we do, let the drudgery be dealt with by automation, and just try it. It's very simple to use, very easy. I very strongly encourage you to play around with this stuff. It has made me way, way more productive in all the things that I do, and I didn't even scratch the surface and all the research stuff. The danger is the chasm between the people who know how to use this effectively and those who don't. We used to call this the digital divide. Where we're headed is the digital chasm. The digital divide was solved by giving everybody access to the internet. But the problem here is a lot of people are afraid or unwilling to learn how to use this, and they're going to get left behind very, very quickly.